In this project, I will demonstrate how to control a servo motor using PWM signal. For this project, I am using FPB-RA0E1 board, groove-based shield for Arduino interface, and a servo motor. Now you can connect groove-based shield on FPB-RA0E1 board. Now connect servo motor on D4JST connector. To control this servo motor, we require a PWM signal with frequency of 50 Hz. To control the servo angle, we need to provide duty cycle from 5% minimum for 0 degrees to 10% maximum for 180 degree rotation. Open Escape Studio and create a new project by clicking on this file icon, then select New, then select Run as C++, then select Run as RA project. After naming your project, click on this Next button. Here select FPB-RA0E1 board from this drop-down menu, then click on Next button. Here select None option, then click on Next button. Here select Executable and No Autos option, then click on Next button. Now select Bare Metal Minimal and click on Finish button. After project creation, IDE will open FSP configurator file by default. Now click on Stack tab. Now click on New Stack, then click on Timers, then click on PWM Stack. We need to provide at least one slave channel for this stack. Now click on Slave Channel, then click on New, then click on PWM Channel. Click on Master Channel, then open its properties. Expand General tab and for period unit select Hz. Now click on period and enter 50 here to generate 50 Hz signal. Now if you observe master stack, it is giving us error related to clock. Now click on clock tab. For PWM source clock, we need to slow down its frequency. We can use divider by 16 to slow down the master clock. As 50 Hz is a very low frequency signal, we need to slow down the master clock. Now if you click on stack tab, you can observe that the error related to master clock is resolved. Now we need to configure output pin for PWM signals. Now we need to select custom option for T01 pin. Now click on this drop down menu and select P100 and then disable GPIO mode for P100. Now if you scroll down and click on T01 pin, error related to P100 have been resolved. Now we don't need to change anything further. Click on Generate Project Content. Now in Project Explorer tab, expand src folder and open halentry.c file. In Project Explorer window, expand Developer Assistant tab, then expand gtimer0 stack. Now from Developer Assistant tab, drag and drop PWM open function call in halentry.c file. Now I will define FSP error variable and then use assert function to make sure PWM open function call was successful. Now from developer assistant tab, drag and drop PWM start function call in halentry.c file. Now use assert function to make sure PWM start function call was successful. Now we can take help from FSP documentation related to duty cycle update function call. Now open FSP documentation and then click on duty cycle update function call. Now I can copy this example in my project. Now I need to define these two variable in my project. Now I am defining this variable as a double because we need to update the duty cycle in very minute fractions. After some observation, I found out that my servo motor will give 180 degree rotation from 2.5% duty cycle to 12.5% duty cycle. So I will start with 2.5% duty cycle and I will increase my duty cycle to 12.5 in minute steps. Now I will declare while one loop here. Let's calculate the duty cycle increment we require for 1 degree rotation. As mentioned, for 0 it is 2.5% duty cycle and for 180 degree it is 12.5% duty cycle. So within 10% duty cycle we are getting 180 degree rotation. So we can divide 10 by 180 and we will get 0.055. In each iteration, we can increment 0.55 in desired duty cycle variable. After that, we can update the duty cycle count variable. Copy the example given in FSP documentation for duty cycle count in while one loop here. Now from developer assistant tab, drag and drop PWM duty cycle set function call in halentry.c file. For third argument, we can use one as mentioned in FSP documentation. Now use assert function to make sure duty cycle set function call was successful. After that, use RBSP software delay to introduce a 100 millisecond delay. After completing 180-degree rotation, we need to reset it to 0. So I am using a if condition here. If the duty cycle percentage is more than 12.5, then we can reset it to 0, which is equal to 2.5% duty cycle. Now we can update the duty cycle count variable. After that, we can use PWM duty cycle set function call. After completing 180-degree rotation, we can introduce 1 second delay. Now we don't need to change anything further. Now click on your project name, then click on this hammer icon to build your project. After the build is complete, right click on your project name, then select debug as, then select NSS GDB hardware debugging. Now IDE will take some time to start the debug session. In debug session, you can click on this resume button twice. Now if you observe the servo motor, it will complete 180-degree rotation. After that, it will go to 0 position. After 1 second delay, it will start to rotate again with 1 degree increment in every step.